Yo, what's up, guys? Welcome back. I think this is the big episode 40, episode 40. Feels crazy that we're at episode 40. I think it is episode 40. It might be 39, actually. Nope, we're at episode 40. Let's look at our Pokemon of the day. We've got a Wigglytuff. Goated Wigglytuff. Must be tough. The wig must be tough. Do the Wigglytuff sound. Let's give it a hear. Wigglytuff. 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 Nice. Good stuff. Yeah. We're going to get straight into our problems. Maybe we can take a look at this problem of the day. This might be a good problem to start with, just a little warm-up problem. Two, three, four, 6. 8 valid tuples. A, B, C, such that A times B is equal to C times D, where A, B, C, and D are elements of nubs, and A does not equal B, does not equal C, does not equal D. Thing is, I think we gotta move around our array. Get our permutations. No? I don't know. How many permutations of 4 numbers? Try to think. Man, that hot chocolate was good, bro. I'm actually not sure kind of where to begin this. Whoops. Let's take a look at the hint. And calculate the permutations formed. So we got to think about I'm trying to think, like, would we double for loop over everything to generate all the parentheses? Would that generate all the parentheses? I don't know. See what the discussion says. Let's take a look at our permutations. I'm not sure how we did it. Pretty sure we did backtracking with this, no? I swear to gosh we did. Oh my gosh, we did this, what, 10 days ago? Jeez, man, I don't remember. Yeah, we recursively backtracked. Do we want to, do we have to recursively backtrack there? I got ender code hidden. Let's go. I don't know if backtracking is necessary in this. I mean, we could backtrack to get all the pairs, but I'm just gonna try and loop over. Let's see what it gives me. I'm actually not sure. Range length. Nums. For J in range length nums. We want to start out this length here from I plus 1, and then we want to create actually let's just have a look at an array first, what it looks like. Let's do array.append I, J, print. I'm thinking of Tucson when I do this. What the oh shit. I'm actually putting in the number, the value. Nums I, nums J. Yeah, we're only getting half, we're not getting all the permutations. I'm honestly not sure. Honestly not sure, dude. It's kind of embarrassing. I feel like I should be able to solve this, but I'm not sure where to begin. There are 16 valid pairs. Did check my email. Nope. Nothing in the email. What an hour. There's definitely some sort of trick to this,
Hey
bro.
everyone, welcome back, and let's write some more Leetcode today. So today let's solve the problem, tuple with the same product. And I really like this problem because it involves a decent amount of math. Now don't worry, when I say math, I don't mean a bunch of formulas that you're going to have to memorize or anything like that. It's going to involve some mathematical thinking, so let me kind of walk you through that right now. So the idea is we're given an array of distinct positive integers. The fact that they're distinct is pretty convenient for us. What we want to do is form all possible tuples of size 4, so there's going to be 4 elements. We're going to call them A, B, C, D, and what this tuple needs to satisfy is that A times B is equal to C times D. And so the thing that you need to remember about a tuple is that the order does matter. So if I draw pretty much the same tuple, but I just swap these two values, it's still technically true. We could also say B times A is equal to C times D. And then we could flip the other two sides. So I'll do A times B first, and then B times A after that. And then here we could have D times C, and we could also have D times C down here. You can see that while the products on both sides are the exact same, we were able to rewrite the equation in 4 different ways. And we could actually get 4 additional ways just by taking all of these and putting them on the right side, and taking all of these and putting them on the other side. I think I said right side a second ago. I meant left side, sorry. But basically, what we've realized is that if we find 4 values that satisfies that condition, then we've actually found 8 tuples. Every time that happens, we found 8 new tuples. And so that's left side, sorry. But basically, what we've realized is that if we find 4 values that satisfies that condition, then we've actually found 8 tuples. Every time that happens, we found 8 new tuples. And so that's why in the first example, you can see that it's not a coincidence that we have 8 over here. And it's also not a coincidence in the second example. We find one formula, 1 times 10 is equal to 2 times 5. Each side is equal to 10, as you can see. And we found a second formula, 2 times 10 is equal to 4 times 5. Each side here is 20. So this is going to be 8 tuples, and this is also going to be 8 tuples, so we end up with a total of 16 tuples. Now, I'm not quite done yet. You might be thinking that, okay, well, there's definitely a brute force solution to this problem that can run in n to the 4th time, and yeah, there probably is. I don't know how easy it's going to be to code that up, because to be honest, I didn't do it. It just seemed like it would have been really tedious, and also that it probably wasn't the intended solution. So I was thinking of some other solutions, and that's what I'm going to show you. I'm going to show you a more optimal solution that actually runs in n² time. But before we can do that, let's try to build up some intuition. One thing that you could say about this second example in particular is that we had two different ways that we could total up to 10. So 1 times 10 and 2 times 5. So basically, for the product that is 10, there were two ways that we could create that number. And same thing with 20, actually. We could form 20 in two different ways. So just to be clear, this is like n1 times n2, and this is the count of how many ways we can form that. If, for example, we had something like 1 times 30, and we could only form 30 in a single way, well, then we can't really satisfy the condition A, B, C, D, where this times this is equal to that. So to me, it's kind of becoming clear that we don't necessarily need to loop over everything. Even if we were looping over everything and we had 4 different loops and the first 2 loops pick these 2 numbers, well, yeah, we could loop through the rest of the numbers and try to find all pairs that have the same exact value as this. Or why not just do some pre-computation, and instead of looking at numbers 4 at a time, why not just look at numbers 2 at a time and then just get the counts of those, and then somehow maybe we can use these counts to determine the total number of tuples. So maybe it's possible. Let's try exploring this. So if I had a mapping like this, and I think it's obvious that probably we'd want to use a hash map or something like that for this, and we
I think I understand what to do. I'm sorry. Then if count in my man, I keep getting a message, bro. Count is greater than 1. So if the count is greater than 1, then we do, wait, hang on. For e value It's the old water. Oops. Items. If value is greater than 1, then we want value minus 1 to get rid of that. No, unorm is equal to value minus 1, and then make our res equal to 0. Then we do res plus or equal value times 8. But this is definitely wrong. Return res, bro. I don't even. I don't think we need that anymore. In China. Unexpected indent. What the? Line 19. Oh. Whoops. Array is not defined. Jeez. It's not even a tuple anymore. Damn, I was actually kind of close. Just call this here now. I don't even know what to call this variable here, so I'm going to call it here now. See, I knew there was some freaking math trick behind this problem, dude. Like, I mean, dude, like, I'm not sure what I'm doing. I think I'm something wrong with this, if I was to guess. I'm gonna check. I'm just not really 100% sure. And it was that. There you go. It's not adding properly. Need some sort of formula, incorrect formula for counting tuples. You're adding value times 8 to res, but this does not correctly count the number of valid tuples and number of ways. Okay, we needed some formula here. Value times, or what the hell is this? Plus 1 divided by 2 times 8. Hi, Spro. I'm trolling my friend right now. I'm honestly not sure why this is the... How to ABC can be arranged 8 different ways. Man, we're doing some combinatorics here, man. Is combination formula value? I guess this is not needed. Let's submit it before we... Oh, there you go. As soon as you started talking about the hash map here and we were counting these values, I was like, you know what, like, it's just this value times that, and that's the answer. But, you know, I'm not too sure. Interesting. Interesting problem for sure, bruh, for sure. I mean, I guess we could, you know, generate the permutations like this, but, you know, maybe... like permutation Leetcode. Here we actually want the permutations. You know what, let's actually do this problem, because why not? I didn't really look at the code, so let's do this. Trying to think. Res. We need I guess we need a current too, right? Def backtrack. Alright, we need what do we need? We get base case, right? So we do recursion, we get base case, exit out our loop. What would our base case be? What would be our base case here? We're returning all possible permutations, so it's 1, 2, 3, 4, 5, 6. So I guess our base case would be if the length of current is equal to the length of nums, then we want res.append code.copy. We just want to return, right? We need our recursive case, right? And in this case, our recursive case would be either what would our recursive case be, man? Man, oh my gosh. Guess we want to do if. Guess we would just want to call backtrack. This is the hard part for me. Think about this. What would be our recursive case? So we're starting with an empty res array, right? So we do backtrack and we pass in our right. Guess we just return res. I guess we either wanna. I guess we either. I'm drawing my friend right now. I'm like 8. He's a full-time software engineer. I'm trying to get him to come on and like do an appearance. And I tell him that we'd make Pokemon sounds, just like the good old days. We used to play like Pixelmon and Minecraft stuff like that together back in the day. But good times. Okay. So I'm pretty sure we have to either pop. I guess backtrack. Maybe we have to pass in I, actually. Trying to think here. I plus 1. And then we get code up pop, or I'm actually not sure the request case here. Man. And all possible combinations to get this, yes. Alright, what am I doing? I can just look in here. Using a for loop, then anchor, continue. Okay, fine. Nums are inca. We break out of that loop. Otherwise, we want to backtrack. Code append I. We want to backtrack. Pop. Get rid of this. Okay. Interesting. I think I just need a little bit more practice with backtracking. I mean, bro, I guess it takes a while to get these problems, but I'm getting the idea. I just like don't know how to like thoroughly execute it. Like that's the issue. Like tough. Anyway, let's check out some more linked list problems. We got one more here, so let's just finish it. Just why not? How long we've been going for? About 40 minutes. Let's take a look at this one. Given the header linked list, rotate the list to the right by k places. Jeez. We got a k, we have a head. So in this case, k is equal to 2, so we have 4, 5, 1. Rotate 1. Oh, geez, this is kind of an interesting problem. Hang on. Given the header linked list, rotate the list to the right by k places. In this case, we have 2. Ah, okay, right. I understand. In this case, we rotate 3. So 1, 2, 1, 0 is here, 2. Second rotate. Third rotate. Fourth rotate. Interesting. I think this is a fairly okay problem. I do kind of have an idea about how to do this one. Yeah, I think there's many ways you can do this. Again, you can kind of do it the cheating way with the array, but I'm going to try and edit this all. I'm going to try and do this like in place with just the linked list and just rotate the pointers. I think kind of the way that we got to approach this problem is that, I mean, we got our 1, we got our 2, we got our 3, we got our 4, we got our 5, right? So I think over the first loop is that we got to find the end value, right? We got to find this value. So we got to loop and make a pointer that points here, right? And then we can finally start making our swaps, right? So we can do a count is equal to k to track our counts, right? Decrement after each time we do this, right? So make a while loop and just decrement and just move the pointer, right? And keep moving the pointer and move the pointer until it's done. So I think that's the way that I'm kind of go about this problem. I don't know if this is the best way to do it. I think it probably is the most efficient way to do it. I'm not sure. Maybe I think that would be an all event approach, but I'm not really all event, but I don't know. Let's just try that. So our cur is equal to head, right? While cur does not equal none. Actually, while cur dot next does not equal none, right? Then we want to do if cur is equal to cur.next. So if cur.next is equal to none. Actually, I guess we can just, because we'd never reach it. While cur does not equal none, cur.next equal to none. Cur.next is equal to none. What do we want to do? We want to set a pointer, so we can do our last pointer. Last is equal to cur. I think that should get us to the end. Let's print our last. I'm going to take a little intermission here really quick. I got to go to the bathroom and tell my roommate something. Why is this not working? Oh, it's not true here. Maybe. Oh. We need a break here. We're in an infinite loop. We got a break. So we're guaranteed to, right? Or is this going to be an infinite loop again? Bruh. Oh, we're not even looping, dude. Jeez. Cur is equal to cur.next. Oh, 5. Okay, perfect. Okay, intermission. I gotta go to the bathroom. Okay, we're back. Alright, so we've got our pointer here. So now we just kind of have to rearrange our pointers. So we can do a while loop here. We can do a count. Count is equal to k. Do a while loop here. While count does not equal. Count does. I mean, if we're gonna do while. Yeah. Well, if we want to rotate twice, 2, 1. Yeah, well, count does not equal 0. Then we do our while loop here, right? So you want to just rearrange our pointers here. Let's kind of visualize this. Oh gosh, I'm gonna sneeze. Technically, what we need to do is that we need to, I guess, break this pointer. Wait, no. Let's just redo this. Hang on. I need to make this smaller, right? So, technically what we have is that we have our head is equal to this, right? 1. Sorry, 1 here. 2. 3. 4. 5. And we're pointing to a none here, right? I think. So we need to change this pointer, break this pointer, move this pointer equal to head. Move this pointer is equal to head, right? I guess swap this. I'm thinking is that we change the pointer so then it goes here. Wait, we want to do that? Can we do that? Or I guess. I think we'd have to rearrange all these pointers. That's the thing. Will we have to rearrange each pointer? Because technically we're moving 5 here. And each pointer goes up by 1. Right? I think. Right, so if we break this node, move this here. Trying to think of a way. I don't think this will work because we need to rearrange these points. That's the thing. So we point, break this. I think we need to break this, right? We would need to break this. And move this, break this to point to here. Right? And we keep going through and keep breaking the points. Right? Because technically, I think we can keep breaking this point and it'll just keep moving forward no matter what. Right? I think. So maybe we need access to this variable right here as well. Let's just try it. Because why not? I mean, I guess we got our cur. I guess we can call this one our prev. Let's do it straight away. We do cur is equal to cur.next, so it's instantly ahead of us. Prev is equal to prev.next. Okay. That's our last. Prev. S last is equal to prev. Prev's equal to head. Print last. Print S last. Okay. Okay, so now we've got a pointer here, we've got a pointer here. So now, I just don't know if this will work. Let me actually just do this really quick, okay? So let's do this. So we have a pointer here. This is our S last. I'll call this SL pointing here. And then we have our last pointing here, right? So obviously what we want to do is we want to break this link, right? We want to, okay. So let's break this link. Actually, hang on. Let's do it like this. We break this link. We break this link and make this equal to here. Right? So then our new pointer would look 5, 1, 5, 1, 2, 3, and 4. Right? And this would still be pointing to S last. This would be pointing to last. Right? And then this would be our head. In this case, this is our head. So how are we going to rearrange these values so that we're constantly looking at the last variable here? That's the thing. I don't know. Is there a way that you can access the last spot in the linked list? Is there a way to access last spot in linked in O of one time? Python. Ooh, maybe there's a tail. Because I'm thinking if we can always automatically access the last element on linked list, then again we still always need we still need access to this one. The thing is always going to change. The thing is, could we automatically reverse our linked list, find the start of it, right? So we have our K. Maybe another way we could look at it is if we could automatically find the start of it by pushing through K elements. So 1, 2. So again, in this case, what are we doing? 2. Right, so 1, 2. We know the start is going to be, after a couple rotates, 2 rotates, 1, 2, we know the start's going to be 4. Alright, so we go from the back. Sometimes if we can always find the start number, then we can maybe rotate from the start. So what I'm thinking is that if we maybe if we reverse our links, can we reverse? If we reverse our links, then technically 5 would be our start. 5, 4. Yeah, I'm not sure. Is there a hint? Hip hop probably was. Convert the linked list to a circular linked list and then shift ahead and the linked list is a circle. Okay. I guess if we think of the linked list as a circle, right? We get to the last element, we cancel this, we make this equal to the here. This equal to here. Man, I'm not sure. I don't know. I gotta ask for a hint. 61 rotate list. Give me some hints. Find the length of the linked list. I don't know, dude. I don't know. Find the new. It's saying here that we need to, since rotating a list by its length results in the same list, compute k, reduce unnecessary rotations. Find the new tail. Ah, okay. I just had a light bulb moment, I think. Okay. So we find the tail, right? So that's what we do. We have the tail is equal to here. That's what we were doing. But how do we break this link? Oh, wait. Can we? Hang on. Well, if we want two rotates, right? Can't we go current on x is 1, current on x is 2? Then we're going to know that this is the point that you want to break, right? We want to rotate twice. We're here, right? So we move twice. We're at 3. We do one more in front of it, k dot next, so that we know that this is the front of the node. We break this link. We break this link. So then we know that we have 4 and 5, right? We know this is the values that we want to put. Then we just we go to the end of this, and then we just make the end of this point over here. Okay, I think that's what we're going to do. I don't know. I kind of had a light bulb moment, so maybe this might work. Let's just try it out. Put this over here so we know what we want to do. So let's get rid of this. Alright, so we want to make, let's make our cur, let's call this our break point, right? So this is the break here. Oh shit, break 1. Let's just do break L for linked list, and then we'll do break break A is break after, right? It's equal to head, right? We need to increase break A. Break A is equal to break A dot next, right? Increase it once. While make our count here. While count is equal to K. While K does not equal 0, we want to move it by 1, right? So we want to do for I does not equal 0, if this is such a good way of doing this, if count minus 1 is equal to 0. Alright, so we know our next value is 0. Oh shit. What am I doing? We can just do a for loop, right? We can loop through this, we can do break L is equal to break L dot next. Break A is equal to break A dot next. Alright, but then we want to make I think that should work. Yeah, that's what we really need, right? Let's print break L. Let's print break A. Or what? Why isn't this working? Non-type object has no attribute next. Okay. The reason is that you can loop outside of this. Shit, you can't do this, man. No, this won't work. We're thinking of one case, bro. That's why we actually have to rotate the array. You know what, I'm just gonna get some extra help. I'm not sure. I'm not sure how to do this. I'm gonna be like, bruh, like when I see the solution, like. Dude, I'm just gonna be so pissed, bro. Okay, so they're looking for the length, right? Tail is equal to head. Okay, final length. Okay, that's what we did originally. While tail dot next does not equal none. Tail is equal to tail dot next. We want to increase our count. It's equal to 1. Here's our tail. Okay, good. He did that. Okay. Now next one, step 2 is to optimize K. K is equal to K% length if K is equal to 0, it's a head, no rotation needed. Why are we checking this though? I'm not sure. I don't get this. Suppose the length of K. So we don't technically need this. Let's skip this step. I understand why we're doing it though. We're doing if the length is, I always get so confused with modules. If the length is the same as the rotation, then we don't need to. Pretty much, because in this case 5 modulus 5 is 0, so we wouldn't need to rotate it all. So I guess, yeah, it's just optimization. We don't need to do that though. I want to actually just understand the problem. Step 3, find the new tail at position length minus K minus 1. New tail is equal to head. Length minus K minus 1. Okay. Range the length minus K plus 1. U underscore tail is equal to U underscore tail dot next. So what are we doing here? We're finding the new tail, right? So this is going to be, this is where we're going to cut, right? So in this case here, cut up. So our new tail here would be the length. So we're, oh wait, hang on. Did we actually, did we print the tail? Did we print the length, man? What the hell am I doing? CDF 4, 1, 2, 3, 4, 5. Ah, that's why we start at 1, I think. No? We want 5, that's our length. Okay, yeah, there we go. Okay. So we want the length of our list is at 5. So we do for x and range length minus k. So we're looping by 1 to length minus k. So in this case, we have length 5 minus k. So what do we have in this case? We have 2 plus 1. So we go 3 plus 1. So it would be 4, right? That would be our new tail. Wouldn't it be minus 1? Oh, whoops, yeah, typo. Whoops, minus 1. Man, we were so close to getting this, bro. I was thinking the exact same thing. Like, so frustrating. Man, I'm so OCD with these, bro. Okay. So this is our new tail, right? New underscore tail. See, the reason why we got it wrong is we were thinking about it in a while loop. We could have just, bro, man, if I had someone else with me. Right, so this is our tail. And pretty much we're just cutting this link. Right? We're cutting this link. This is our new tail. We're making our tail equal this. Alright, so let's do that. So let's reconstruct. Right, so we have, let's follow this. What are we gonna do? We gotta cut our link with new tail, so you underscore, let's go tail dot next is equal to none, and then we make our tail equal to tail dot next is equal to head. Right? And then just equal to head. Now what would we return? We'd return, so now technically our list looks like we'd want, we lost this link. Technically we want, this would be our head, right? So we lost this link. Now we want to move here. So we want to return this value, right? So we need to make a new underscore our head is equal to new underscore tail dot next. Then we reconstruct it here and we return our head. That should return us the, man, I would have got this, bro. So sad, bro. Oh, maybe we got something wrong. Memory limit exceeded. Why? It's because we. Oh no. Head is equal to new tail dot next. Why? What is wrong, dude? I don't even know what's wrong here. I thought we tested this. Edge cases. What if head is none? Oh shit, I have edge cases. Okay. If head is none, turn head. Incorrect handling when k is greater than or equal to the length. You should reintroduce k. Maybe we need the optimization. Maybe that's what it is, actually. Really, dude? The optimization? Optimization. If equal to k, if... Sorry, k is equal to k percent length. If k is equal to 0, turn head. Bro, what is wrong here? Am I doing something wrong? Because I'm making this? I don't know. You tell that next equal to none? Yeah, I've got it all right. Alright. Four. Bro, I don't know. I've got something wrong with this loop, I think. The fuck? No, I don't. It's equal to head. Bro, it has to be this, dude. It has to be this. I mean, I don't think we need this optimization anymore because it's not going to do anything. It has to be the edge case over here. If not head or not head.next. Or k is equal to 0. We return head. Like, bro, what the hell? I generally have no idea. What? I'm getting the wrong index or something. K is equal to 4. Bro, I'm like going insane here right now, bro. Like, who's this? Bro. Avoid unnecessary full rotations. No change in the list. But why is this? I didn't think this was needed, bro, but apparently it is. So I generally don't understand. Finding the length here. If k is equal to 0, return head. Yeah, bro, what the hell? Not head, right? Return head. So if our list is empty, our length is equal to 1, and our tail is equal to head. Okay. While tail.next does not equal none. Tail is equal to tail.next. Length plus equal to 1. Right? Okay. K is equal to K percent length. K is equal to 0. Turn head. I in range length minus K minus 1. Right, this is exactly what I did. Yeah. Cur is equal to cur.next. Okay, this is exactly what I did. But why? I thought it was unnecessary, honestly. Like, okay, I understand what this is doing. So this is, one is checking if k is equal to 0, because k is equal to 0, then we don't need to. It's just the same list, right? But if k is greater, then technically it's just going to return the remainder. So if it's 7 over 5, it's going to return 2, because technically we only have to return 2. We don't really have to do this 2 times. I think that's where it's messing this up. Optimization was unnecessary. But how? Then the optimization works. Like, telling me Okay. I think that's why you need the optimization here, because you're going to keep looping through. This will loop over the amount. But why? Okay. I understand. This is making sure this works. I didn't realize that. I didn't even, when I'm thinking about this problem, I wasn't even thinking about when it goes over. I guess that's something that you have to always think about. Interesting problem. Alright, we're going to call it here. I got some things to do, so I appreciate you guys watching, and we'll get back at it tomorrow.